Hi class, welcome back. We're gonna do a quick review on graph functions and their parent functions. This serves to help you answer question number 4 and question number 5 from the prerequisite P.5 functions and numerical, algebraic, and graphical viewpoints of and basic functions. So this is a quick review, but also a great opportunity for us to explore Desmos. So we're gonna be matching the graphs from the problem to here. Now, what I did here was I presented all the functions that we have, which are mainly the ones that we're gonna be seeing in our class. One that is not in the assignment is the constant function. If you notice this one, and what we want to also remember is what does it mean to be f of x? F of x is replaces the y value, right? So we can write it in both ways. We can say f of x equals 2 or y equals 2. And when we look at graph, we know that this is our y-axis and this is our x-axis. And every point on the line is represented by an order pair. For example, if you had this at 2 and this at 2, then this point would be 2, 2. Now we do have to be careful because the way we measure this direction is the x-axis, which is the x value. Maybe I'll write it here, x, and this is y. So let me give another example. If we had the value, let's say 4, and this is at 2, then this point corresponds to the coordinate 4 and 2, and we would write it like this: 4, comma 2, where this order pair means that the order for which they appear, it matters, right? So being the first digit that appears represents the x component, and the second value represents the y component. So the order for which they appear matters, and pairs means that they come in pairs, right? They come in 2. So we have so basically what we're saying here is that there's infinite points in here that compose this line, and this is true for every line. And in order for you to complete all that space in between them, right, every point you're gonna have infinite points, right? Infinite points. We usually don't talk about too much about that, but the line is continuous, so therefore it has continuously infinite points in between. So alright, so having said that, we're gonna refresh our minds, and when we use the other types of functions. The other one that we use, it's common for us to use, is the linear function, and this is the case that we have here. These two are linear functions, right? These are linear functions because they compose a line, a straight line. So these are called linear functions. Then we have the absolute value. The absolute value, if you guys remember, is a way for us to measure by definition, is the distance of the value from 0. So but pretty much the way we see it in the function is that whatever number you plug in there, the absolute value is going to turn in positive. So if you plug in x equals 2, then 2, absolute value of 2, will become 2, so y is positive 2. If you have x equals negative 2, then when you plug in negative 2 into the absolute value, the absolute value is going to turn in positive, and so there you have negative 2, 2. So there you have that point. So and then so on, right? So if you continue to do a table of values, these are different because these do not follow a straight line. They have a curve, and that's kind of important in this class. So what we can do here is to be able to sketch this, is we can kind of think about them as creating tables and plugging in different values from there. So x and y. So we can plug in, for example, -2. When you plug in here, that gives you +4. When you plug in -1 in here, -1 times -1 is +1. When you plug in 0, you get 0. 1, you get 1, and then 2, and you get 4, and so on. So of course, I'm not going through every single one, but we will see that every point that we have, 2 +4, 1 +1, 0 0, -1 is 1, and -2 is +2. So these become order pairs of the function. All right. So now we do have other tools that we can use, technology we can use, but what I want to point out here is the rest of them, which is the cubic, and then we have the square root, which if you notice here, it just starts here and then it goes in that direction forever. These all go forever in that direction. Same thing here. They all go in the infinite direction. Maybe I should just write it out. Let me put that in here. So infinite, infinite, infinite. Yeah. Okay. All right. And then here it's stopped right there. So okay. And then the next one we have is the cube root, and the cube root, it's almost like the square root, but it goes continuous. And then we have the reciprocal, 1/x, and then we have the reciprocal square, which if you notice is almost like the reciprocal, but this part is on this side, is reflective. Now I want you to point out that we know that the quadratic and the square root are inverse of each other. If you notice, if you take this and you lay it down, right, it would look like that. So if you notice, that's actually what you have there, except this part. And in order for this to be a function, you have to kind of remove that part, because remember, it has to pass the vertical line test. If you notice here, the same thing with the cubic. The opposite of a cubic is the cube root. So we notice this is the same thing, just laid down in there. All right, so let's jump into Desmos, and let me bring it out here, and let me have both of them at the same time. All right, so what we're gonna do is here we're gonna type in, we're gonna mess around with these, and let's focus on the absolute value first. All right, so let's just do the absolute value. I'm gonna minimize this a little bit. Here we go. All right, so how we're gonna type that in? So Desmos is an online software. You can access that by using your search engine and typing Desmos. You can also download the app to your smartphone, smart device. So here we go. So I'm going to do is I'm going to go ahead and write the function. So I'm going to go ahead and write it. I'm going to type in, and it's not letting you type it, so it's going to be y. So I'm going to go here in the bottom part, and I'm going to say it's equal, which is in the bottom part, and I'm just going to say x. All right, so that gives me the first one, right? This just gives me this one. But in order for us to make it absolute value, what we need to do is, go back and erase that one. So let's erase it over here. And it's easier if you have an actual desktop. And then if you notice here, we have functions. And if you scroll down, you have more functions. So you have other functions that we can use later on. If you notice on the other side over here, on the left side, we have the x, the y, a squared, b, a to the b, parentheses, the square root, but you also have absolute value of a. So if you plug in that right there, the absolute value there appears. You type in x, and then you close the absolute value, and there you go. So that gives you the absolute value. What you can do with this is also you can do multiple graphs at the same time. But let's type in the y square. So we're going to type in y equals, and then x, and then square it. There you go. And then if you click down here, you can do it again. So y equals x to the third power. So we're going to use where it says a to the b. That's going to allow you to take an exponent, and then that gives you x cubed. So that's that one right there. If we want to do the square root, so we'll do that right here. Excuse me. It would be y equals, and then underneath on the bottom part there is like a, next to the pi there's a square root symbol, and then you type in x, and there you go. And what you can do here is also you can erase the other ones by touching the circles, and that gives you the other ones. That way if you wrote something you can still continue to write them out, right? Let's do the cube root. So we have the cube root. Let's see if we can try the cube root. So we y equals the cube root of x, but we're gonna have to move to the left side. Let's see what happens. No, yeah, we can't. So what we need to do is think about the cube root as an exponent. So let's try to do this. So if you want to write the cube root, and I'm gonna write a note here, is the same thing if you write this as x to the 1/3 power. So let's do that. And you type in 1/3 as an exponent, and there you go. It gives you the cube root. Let me see if those appear down here. Yeah, right here. So we can also use this one. So let's try that again. Let's do y equals, and then go functions, and all the way to the bottom you have an option to type in the nth root, and that will allow you to put the index of the root, and then you click it with your mouse inside the radicand, and you type in x, it gives you that. So if you notice, if I hide the red one, right, it's right there. If I click the blue one, they're both right, so we can see both of them. And then finally we can just talk about the last one, which is y equals, and then 1/x divided by x. There you go. And then we'll do one more, y equals 1/x squared, and then we see the purple one right there. All right, so I hope you guys found this helpful. I encourage you guys to practice using Desmos, and then this will serve you both for question 4 and question 5. All right.